Now we're going to go to fluid rates in terms of liquids themselves. Here's a small slide from a basically grade 12 first year university physics note, and it's showing fluid rate down a pipe. You'll probably, if you take the right courses, do this before you leave high school. And it's not that difficult, just to scare you a little bit here. You start studying fluid rates in about grade 12 physics. And at first you might go, what am I doing, studying how water goes to my toilet? Well, yeah, it does work for that. But this is also how your heart works, turbulence in the blood flow of your brain. The rockets and jet engines we build are all fluid dynamics. And it even works out in terms of a lot of stars and things and how material moves around the universe. So it's a really important concept, but totally dodgeable if you decide not to take physics. Now, this is where water and electricity kind of bang into each other, okay? Fluid rates is called current and is the quantity per second. The letter I is used for this, okay? Now, why is I being used for current? Well, you can read at the bottom of the page, a Frenchman named it intensité du courant, which is why it's I. Science is global. We tend to keep the short forms used by scientists around the planet in honor of them. So we're going to see an awful lot of these measurements in electricity are from France and Italy. The total quantity uses the letter Q, so I is flow. Trying a simple example. A 600-liter tank drains in 5 minutes. Calculate the flow rate in liters per second, not per minute. So first of all, what were we told? We were told the quantity is 600 liters. Next, we were told 5 minutes. But 5 minutes times 60 seconds in a minute is 300 seconds. So this makes sense. 600 liters in our tank came out in 300 seconds. We had a flow of 2 liters per second. And I kind of know what this is like because I broke a 600-liter tank in this classroom years back, cracked the bottom, and it took a couple minutes to drain, but it really washed the desk, the drawers, the floor. So that was the best cleaning they ever had. Let's take a look at what current flow looks like. Which one of these is a high rate of flow? Which one's low? Your first reaction might be to a kid that this water is moving very fast and this one is moving very slow. Yeah, but look at the size of this river. There's probably a lot more current, liters per second, flowing down that river than this one. Your math teachers are going to show you how to rearrange current or flow or rate. They're all the same kind of term. A rate in water we tend to call the current. But in science, I can show you how we can use logic. Okay? So math teacher might give you a formula, but think about it. You're driving at 80 kilometers an hour for 3 hours. How far have you traveled? What do you do with those two numbers? Common sense. You get paid $17 an hour and work for 6 hours. How much are you paid? A water fountain is stuck on, flowing at 3 liters a minute. It is left on for 24 hours. How many liters of water are wasted? What are you going to do with these numbers to get your answer? Can you write it down as a general formula using the letters Q, I, and T, what you're going to do? So traveled and how much are you paid are quantities. These are rates, the letter I, and this is time. What did you do with I and T to compute Q? If you know what you did with these actual examples, replace that with the letters Q, I, and T. So did you do 80 divided by 3 equals the distance? What did you do? And change it to letters, and you now have a formula. So I think what you realized was Q is equal to I times T. So flow is quantity over time, but quantity is flow rate times time. Let's go back to an example using money. Jim is paid $200 an hour for 10 hours work. What is his rate of pay? Well, it's Q over T, $200 over 10 hours equals $20 an hour. Why have I put the units in blue? Because you're going to want to drop them. Kids just want to do math class and have a unitless answer. Now, why did I put the dollar sign over on the right? I'm trying to show you what we really should have been doing with the dollar sign throughout history. $20 per hour. You can see a rate. The dollar is the quantity. I'm not putting the mouse there because that pop-up will show up. So the dollar sign tells us our quantity. All other quantities we've ever invented go on the right side of that bloody number, not behind in front of it. Now, my dear friend Naranjan Tembutire in university gets $15 an hour and he works an 8-hour shift. What is he paid? I think you'll realize that you need to multiply those two. So you start by writing the formula Q is equal to IT. Then you put, you can't block me now. Then you write $15 an hour times 8 hours and you get $120. What's with my notation? What I'm going to strongly encourage you to do is write the brackets instead of the times symbol. Why? Because by the time you write $15 an hour times 8 hours, you're going to have a mess of numbers and letters, and guaranteed by grade 11, that practice is going to become a nightmare when you start using X's and Y's. You go, is that X times Y or is that X squared Y? What is it? So what I would do is put in brackets and fill your numbers in later and make sure you keep those units. Don't let them go. Now, what are you really going to be doing at work? Calculating how many dollars an hour you're getting when the boss gives you a paycheck? Or does the boss tell you your rate of pay and you calculate how much you're going to make tomorrow? Which do you do more often? I think you'll find in most cases you're calculating the quantity. Now, here's a water flow example. I tell you there's a quantity of 1,000 liters in the tank. It's coming out at 100 liters an hour. How long will it take this tank to drain? What would you do with those two numbers to calculate the time to drain? Now just say it in plain English. 1,000 liters. And you're taking out 100 every hour. How long will it take to drain? You're going to do quantity and then you'll divide it by the time. Okay? Imagine if you went to France and you had $1,000 in your pocket and you were spending $100 a day. How many days have you got before you're broke on vacation? What you're doing to compute the time is taking the quantity over the flow. And you just do this. So, common sense, you can calculate either I, Q, or T by turning it to a money or water example, and you'll easily see what you should do. Now, what about figuring out how much is in this water tank from the flow rate? The tank drained at 100 liters an hour, and it took it 10 hours to drain. How do we figure out the total quantity? Well, we've been given I and time. So what would you do? If you made $100 an hour and you work for 10 hours, what do you make? If you're taking 100 liters an hour and it took you 10 hours to empty the tank, what do you do with your two numbers? I think you'll see it's this. You multiply them. You get your answer. But if you're lazy, you might answer it like this. Hey, I don't know exactly, but it flowed at 100 liters or 10 hours. It implies the total without actually calculating it directly. So you could actually say, the total in the tank, man, it's 100 liters an hour for the frickin' 10 hours. What do you want me to do? Calculate it? And your science teacher goes, well, actually, that would be more desirable than giving me that smart-ass answer you just did. Certainly wouldn't be like if you were a flight engineer on a plane. Silvio, how long are we going to take to use up our fuel? Do we have enough fuel to make the Canary Islands? So, look, don't bust my chops. The plane's using 100 liters an hour. We've been flying for 10 hours. You do the math. But that's why you're the flight engineer. And it's like, I don't get paid enough to look at the fuel gauges. And you get that kind of lip. Now, do you understand the concept? Is 100 kilometers an hour the same as 100 kilometers? Which one of these is the highest rate? 20 kilometers an hour, 5 kilometers a minute, or 100 meters a second? You have a 40,000 liter swimming pool. You have a choice of a 20 liter a minute water hose or a 20 liter per second fire hose. Which one can't possibly